With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, I'm going to explain this question, and the question is: a larger spherical mass m is fixed at one position and two identical point masses m are kept on the line passing through the center of m. The point masses are connected by a rigid massless rod of length n, and this assembly is free to move along the line connecting them. All three masses interact only through their mutual gravitation interaction. What is the point when the point mass is nearer to m at a distance r is equal to 3l from m, the tension in the rod is 0 for m is equal to k capital M upon 288, value of k. So basically this is the mass m which is fixed, and there are two masses m and m. They are connected with a rod. So at a distance r is equal to 3n, the tension in the string is 0. So what will be the value of k if relation between m and capital M is given? All right. So basically to see this mass can, like, the tension is 0. It means there is like no, either the block this mass is at rest, or this nearer mass is at rest, or this mass is moving with certain acceleration towards the radius, towards the capital M, right? Now let's look at the possibility: can the mass be at rest? If there is acceleration in the opposite direction, then there definitely will be tension. So if, let's say, this body is at rest, right, the force by this the body on this one will be due to this capital M, that will be along this direction. Let's call it F1, right? And the force by this other mass, that will be along this direction, let's just call it F, right? Similarly, if these are equilibrium, then F1 should be equal to F. Now the force on this will be the force F, that is by this mass, this will be same as F in magnitude, and the force by this bigger mass, capital M, that will be, let's just call it F2. As we can see, F and F2 are same on both the body, right? But on the later body, on this body, so this body cannot be at equilibrium, and since they are connected with rod, so if this is at equilibrium, then it should also be at equilibrium, unless that cannot be possible. So since this body and this body cannot be simultaneously at equilibrium, so we have to assume that both the body are moving with a acceleration a. So we have to assume that the body, this rod, this mass and this mass is moving with acceleration a. So in the first case, we will get F1 minus F is equal to ma, right? And in the second case, we will get F2 plus F is equal to ma. So adding this, we will get F1 plus F2 is equal to 2ma, right? Okay, we need to eliminate ma, right? We are like, so we have to subtract it. So if we subtract it, we will get f1 minus f minus f2 minus f is equal to 0, which gives us f1 should be equal to 2f plus f2. All right, this should be the equation in order to have a like no zero tension on the string. So we can easily find the value of f1, f and f2, right? So f1 will be our, so let's put the values. So f1 will be g capital M, m upon value of r, that is 9 3l, that will be 9 and l square, should be equal to, okay, this 2f 2g, and for f will be mm upon small m divided by distance between them is l square, plus f2 will be g capital M and small m divided by value of distance, that is r plus l, that is 4l, which will give us 16l square. Should this should hold true in order to have a zero tension. So let's solve it. So g m and l square can be cancelled, so we got gm. Okay, let's cancel the g. So let's cancel g 1m l square everywhere. Okay, this m, not this m, will be cancelled. So what we got is m upon 9 is equal to 2m minus m upon 16, sorry, plus m upon 16. So this will be, let's take it on the left side, m upon 9 minus m upon 16 is equal to 2m. Okay, so we got 16 minus 9 m upon 16 into 9 is equal to 2m, which gives us 7m, right? 7m upon 16 into 9, that will be 144 into 2, that is 288 is equal to m. So we got m is equal to 7m upon 288. So this is exactly asked, right? M upon m. So k will be 7, right? So our answer will be k equal to 7. Alright, this was the explanation. Hope you understood it. Bye bye.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.